Imagine for a moment a world so impossibly small that our everyday rules simply unravel. A realm where particles can be in two places at once, where observing something changes its very nature, and where the future isn't simply uncertain but a dizzying array of probabilities. This is the quantum realm, a place of profound mystery and often bewildering chaos. For decades, scientists have grappled with the inherent unpredictability of these miniature systems, feeling as though they were trying to grasp smoke with bare hands. The more closely they looked, the more enigmatic it seemed, a swirling, formless storm of energy and possibility. Yet, amidst this swirling uncertainty, a remarkable pattern began to emerge, a discovery so profound it challenges our very understanding of chaos itself. What if the most chaotic aspects of the quantum world weren't merely random, but followed a hidden, unwavering rule? What if the storm, no matter how vast it became, retained a curious, unyielding intensity? This intriguing question led to a breakthrough that could, quite unexpectedly, revolutionize the future of computing. Our journey into this revelation begins with the very essence of chaos. In our macroscopic world, chaos is often seen as a system spiraling out of control, a butterfly flapping its wings in Brazil causing a tornado in Texas. Small changes lead to massive, unpredictable outcomes. But in the quantum domain, this concept takes on an even more elusive character. The inherent uncertainty, the probabilistic nature of everything, makes charting a clear path almost impossible. It's like trying to predict the exact path of a single autumn leaf falling in a hurricane. This fundamental quantum chaos has long been a significant hurdle, particularly as we venture into the ambitious field of quantum computing. How do you build stable, reliable technology when its very foundations are so profoundly erratic? Then came 2021, and with it, a discovery that reshaped this perception. Researchers were meticulously examining quantum data storage systems. Picture tiny, incredibly delicate repositories of quantum information, like microscopic libraries holding fragile, flickering bits of data. To probe these systems, they introduced laser light, a focused beam of energy designed to interact with and influence these quantum elements. Their expectation was straightforward. The energy from the laser would inevitably increase the system's chaotic behavior. It would stir the pot, so to speak, making the quantum information even more haphazard and difficult to manage. And indeed, this initial observation held true. The systems became increasingly chaotic. The quantum bits, or qubits, behaved more erratically, their states becoming harder to pin down. But then came the profound surprise, a moment of scientific wonder that shifted their entire perspective. As they scaled up their experiments, adding more qubits, making the quantum data storage systems larger and more complex, they observed something truly counterintuitive. While the systems were undeniably chaotic, the extent of that chaos, its fundamental intensity, remained precisely the same. It didn't grow exponentially with the system's size, as one might expect from classical chaotic systems. It was a constant. This stable, unyielding level of chaos, regardless of the system's scale, is what scientists have termed quantum hyperchaos. Think of it like this. Imagine a turbulent river. You might expect that the wider the river, the more powerful and unpredictable the currents would become. But with quantum hyperchaos, it's as if the river, no matter how wide it stretches, maintains the exact same degree of internal turbulence. The flow is chaotic, yes, but its inherent level of disorder is fixed. For researchers, this was a revelation. It suggested an underlying order within the seemingly untamable wildness of the quantum world. It wasn't just chaos, it was a quantifiable and stable form of chaos. The implications of this constant chaos are truly remarkable, particularly for the future of quantum technology. Quantum computers, in their nascent stages, are notoriously fragile. Their exquisite sensitivity to their environment means that even the slightest disturbance can cause errors and lead to what's known as decoherence, where the quantum information is lost. Managing or mitigating this inherent instability has been one of the biggest challenges. But what if this constant chaos isn't a problem to be solved, but a feature to be harnessed? The research team believes that understanding and potentially harnessing this unwavering degree of chaos could be the key to significantly improving the processing power of quantum computers. If the fundamental level of chaos in a quantum system remains constant, regardless of its size, it means that as we build larger, more powerful quantum machines, we might not necessarily face an insurmountable increase in chaotic instability. This could lead to more robust qubits, better error correction mechanisms, and entirely new ways of designing quantum algorithms that thrive rather than falter in this predictable unpredictability. Imagine a quantum computer that can reliably perform complex calculations precisely because its chaotic nature is understood and integrated into its design. This discovery of quantum hyperchaos reminds us that the universe, even in its most bewildering corners, often holds hidden symmetries and profound order. What appears at first glance to be random noise can, upon deeper inspection, reveal a stable rhythm, a constant hum that can be tuned and utilized. It's a testament to the persistent curiosity of the human mind, always seeking to find patterns in the seemingly patternless, and to transform perceived limitations into powerful new possibilities. So, the next time you hear about the baffling world of quantum physics, remember quantum hyperchaos, a testament to the idea that even in the most tumultuous of realms, there can be a surprising, unyielding constancy. And it's this constant chaos that may just be the key to unlocking a future of unimaginable computational power. What do you think about the idea of harnessing chaos for technology? Could this discovery change our fundamental understanding of complexity itself? Share your thoughts in the comments below. And if you found this exploration intriguing, consider following for more journeys into the remarkable world of science and discovery.